Hi, welcome to Chapter 7, Part 4, where we're going to talk about trends within a couple of groups and some nonmetals. So group trends. Elements in a group, they have similar properties, and they're also trends within the group. So some of the groups we're going to look at are the alkali metals, which is the group 1A metals, the first column on the left of the periodic table. The alkaline earth metals, which is the column right next to it. The oxygen group, the halogen group, the noble gases, and why hydrogen is a nonmetal. So let's talk with the alkali metals. Where are the alkali metals located on the periodic table? They are the first group, or the first column on the periodic table. These are the most reactive metals. Some properties of your alkali metals are they are soft, metallic solids. As you can see here, they are slicing. I believe this is sodium. Okay, they are found in only in compounds in nature. You're never going to find them alone because they are so reactive. They don't just sit there; they react with stuff. They have typical metallic properties like luster, conductivity. They have a low density and melting point. They also have low ionization energies. This low ionization energy is why they are so reactive. It is very easy for them to lose an electron. And for metals, if you lose electrons easily, you are very reactive. So metals that lose electrons easily are reactive. Because the act of losing that electron is it reacting with another substance. So here is a picture of lithium, sodium, and potassium, and if you looked at your periodic table, we are going down, and notice that it gets more reactive as we go down the group or family. All right, these metals are notoriously for their exothermic reactions, okay? So why do the reactions with water get more vigorously as you go down the periodic table? Well, think about our trends that we talked about the last couple days. What happens as we go down a group or family? The size of your atom increases. And in particular, your valence electrons are further away from the nucleus. Because they are further away from the nucleus, your ionization energy decreases. Which means as you go down a group or family, it is even easier to remove an electron. And the ease with you could remove an electron, this explains how reactive it is. So if you can remove an electron even easier, your substance is going to be more reactive. So there are some differences in the alkali metal chemistry. First of all, lithium will react with oxygen to make lithium oxide. And sodium can react with peroxide. Remember, peroxide is O2 with a -2 charge. And it'll make sodium peroxide. And potassium, rubidium, and CS here will form what's called superoxides. Superoxides are O2 with a -1 charge. We don't see this very often. This one we see a little bit more often than that, but not much. Okay. Also, if you remember back to our spectral line lab, certain elements will produce certain colors because of the electron transitions. So here you see lithium will make a red color, sodium yellow, and potassium a pretty purple color. So your alkaline earth metals are the second column or group in the periodic table. These metals have a higher density and melting point than the alkali metals. Their ionization energies are low, but not as low as the alkali metals. Because remember, what happens as you go across to your ionization energy? Ionization energy increases. And this group is to the right of the alkali group. They will readily form +2 cations, so they like to lose 2 valence electrons. Beryllium does not react with water, but magnesium, and magnesium will only react with steam, but the other metals will react, okay? So reactivity trend tends to increase as you go down a group. So as you go down the group, reactivity increases, and it's for the same reason the alkali increase, because as you go down a group, your ionization energy decreases. So you can lose an electron more readily. Group 6A is kind of a hodgepodge, right? You start at the top, and you have oxygen, sulfur, selenium, tellurium, and polonium. So these guys here are the nonmetals. Tellurium is a metalloid, and polonium is a metal. So you have all 3 types of elements in this family. Okay, oxygen is more likely to form a -2 anion, and polonium is more likely to have a positive charge. So it's kind of weird. You have a mixture of everything in this family. But as you go down the group, you get more metallic. So let's talk about oxygen a little bit. It has 2 allotrophs. All right, allotrophs means that it is the oxygen can exist in 2 different elemental forms. So you have O2, which is the most common, and ozone, O3. Oxygen can form 3 ions: the oxide, the peroxide, or the superoxide. Most of the time, we're dealing with this one. Oxygen tends to take electrons from other elements. So that's oxidation. If you look at sulfur, sulfur's most stable form is S8, and it kind of forms this ring. The halogens. The halogens are all nonmetals. Okay? They have a highly negative electron affinity. So they like to form anions. They like to gain electrons. Okay? So they'll react directly with metals to form metal halides. And chlorine is used as a disinfectant in our water. So what you need to realize is, so we have fluorine, chlorine, bromine, iodine, and AT. Okay, these 3 here, these 2, the top 2, gas. This one's a liquid. And then the last 2 are solids. And since nonmetals want to gain electrons, that is how you define their reactivity. If a nonmetal gains an electron very easily, it is very reactive. So if it gains electron very easily, it is very reactive. So as you go down the group here, the reactivity of your halogens decreases. The reactivity decreases because it gets harder for it to gain an electron as you go down, because your atom's getting larger. There's less force of attraction to gain the electron. And if you look at the trends in electron affinity, you'll see that as you go down, the electron affinity is less negative. So fluorine is the most reactive halogen. And think about when we were doing single replacement reactions, fluorine would always replace everything below it, right? So if I had this reaction would occur, but if I did the opposite, this reaction would not occur. So this trend is opposite of the metals. The metals, as they go down the group, they get more reactive. The nonmetals, as they go down the group, they get less reactive. Now your noble gases, which used to be called inert gases because they were believed that they would not react with anything, have very large ionization energy. So it takes a lot of energy to remove an electron from it. So most likely it's not going to happen. Your electron affinities are highly positive, so they really don't want to form anions. Therefore, they're relatively unreactive. Okay, most of them are found as monoatomic gases. So like helium, you just find helium gas. But in the late 1960s, up until even the 2000s, they've been doing experiments with these noble gases to see if they can make them form compounds. And what they found was that xenon, krypton, and argon can form compounds in special cases when they are reacting with special compounds. So they dropped the name inert and call them noble gases now because some of them will react. And last but not least is hydrogen. Hydrogen has a 1s1, which puts it in group 1, but it is not part of the alkali group. Hydrogen acts more like a nonmetal. So we do think of, when you think of acid compounds like HCl, hydrogen has a +1 charge. So it's really more covalent in nature, so it's acting like a nonmetal. Hydrogen can act like a metal, or when hydrogen reacts with a metal, it forms a hydride. So you could have sodium hydride. In this case, hydrogen has a -1. But in this case, we say hydrogen has a +1, even though it really doesn't have a charge because it is a covalent and they're sharing. And that is the end of this section.